Well, hello everyone. Welcome to my channel. My name's Jasmine, and this here I will be doing TryHackMe's pre-security learning path, but on the section of Linux fundamentals. And just to inform you ahead of time, I will not be going through the answers or showing you the labs and simulations. There's plenty of YouTube videos where they go through the walkthroughs, and TryHackMe and their YouTube channel already has like a better presentation of this module. So you may as well go to their channel and look it up yourself. And if that's the case, thank you so much for stopping by, and you have a wonderful day. Also, I'm only making this video so I can provide documentation and practice my public speaking. So here's Linux fundamentals. It says many servers and security tools use Linux. Learn how to use Linux operating system, a critical skill in cybersecurity. Linux Fundamentals Part 1. Embark on the journey of learning the fundamentals of Linux. Learn to run some of the first essential commands on an interactive terminal. Task 1 is Introduction. Welcome to the first part of the Linux Fundamentals Room series. You're most likely using a Windows or Mac machine. Both are different in visual design and how they operate. Just like Windows, iOS, and Mac OS, Linux is just another operating system and one of the most popular in the world, powering smart cars, Android devices, supercomputers, home appliances, enterprise servers, and more. We'll be covering some of the history behind Linux and then eventually start your journey of being a Linux wizard. This room will have you, 1. Running your very first commands in an interactive Linux machine in your browser, 2. Teaching you some essential commands used to interact with the file system, and 3. Demonstrate how you can search for files and introduce shell operators. And like I said before, I'm not doing the questions or the labs. Please go on their website. Okay, Task 2, a bit of background on Linux. Where is Linux used? It's fair to say that Linux is a lot more intimidating to approach than operating systems such as Windows. Both variants have their own advantages and disadvantages. For example, Linux is considerably more lightweight, and you'd be surprised to know that there's a good chance you've used Linux in some form or another every day. Linux powers things such as 1. Websites that you visit, 2. Car entertainment or control panels, 3. Point of sale POS systems such as the checkout tills and registers in shops, 4. Critical infrastructures such as traffic light controllers and industrial sensors. Flavors of Linux. The name Linux is actually an umbrella term for multiple OS that are based on Unix, which is another operating system. Thanks to Linux being open source, variants of Linux come in all shapes and sizes, suited best for what the system is being used for. For example, Ubuntu and Debian are some of the more commonplace distributions of Linux because it is so extensible, i.e. you can run Ubuntu as a server such as websites and web applications, or as a fully fledged desktop. For this series, we're going to use Ubuntu. Similar to how you have different versions of Windows, like 7, 8, and 10, there are many different versions or distributions of Linux. Task 3. This room has a Ubuntu Linux machine that you could interact with all within your browser whilst following along with this room's material. And you usually click Start Machine right here, but I will not be doing that. However, to get started, simply press the green Start Machine button on the top right of this task, indicated by the arrow on the right. Once deployed, a card will appear at the top of the room. This contains all of the information for the machine deployed in the room, including the IP address and expiry timer, along with buttons to manage the machine. Remember to terminate a machine once you are done with the room. More information on this can be found in the tutorial room. For now, press Start Machine, where you will be able to interact with your own Linux machine within your browser whilst following along with this room. And so they have a picture here, or a screenshot, of what it's supposed to look like. You could visualize. Task 4, running your first few commands. As we previously discussed, a large selling point of using OSs such as Ubuntu is how lightweight they can be. This, of course, doesn't come without its disadvantages, where, for example, often there is no GUI, which is graphical user interface, or what is also known as a desktop environment that we can use to interact with the machine, unless it has been installed. A large part of interacting with these systems is using the terminal. The terminal is purely text-based and is intimidating at first. However, we will break down some of the commands. After some time, you will quickly become familiar with this terminal. Here's a picture of what it's supposed to look like when you're doing their lab. We need to be able to do basic functions like navigate to files, output their contents, and make files. The commands to do so are self-explanatory, and once you know what they are, of course. Let's get started with two of the first commands, which I have broken down in the table below. The command echo is to output any text that we provide. So what you give out when you type in echo, you would get the same output that you provided. And the command, who am I, is how to find out what user we're currently logged in as. And that's what it's supposed to look like when you put echo, hello friend, and who am I. Task 5 is interacting with the file system. So far, we've only covered the echo and who am I commands. Not all that useful when you consider things that we need to do, which is including navigating the file system, read and write to it as well. In this task, we're going to be learning the commands so that we can do just that. Just like the previous task, I'll display the commands in the table in the next heading and show examples of these commands being used. Interacting with the file system. As I previously stated, being able to navigate the machine that you're logged into without relying on a desktop environment is pretty important. After all, what's the point of logging in if we can't go anywhere? So the command ls is, its full name is listing. The command cd is change directory. The command cat is to concatenate. And the command pwd is to print working directory. Listing files in our current directory, which is ls. Before we can do anything such as finding out the contents of any files or folders, we need to know what exists in the first place. This can be done using the ls command, which is short for listing. There's a screenshot of what it's supposed to look like. In the screenshot above, we can see there are the following directories and folders. 1 is the important files, 2 is my documents, 3 is notes, and 4 is pictures. Great, you can probably take a guess as to what to expect a folder to contain given by its name. Changing our current directory, which is cd, now that we know what folders exist, we need to use the cd command, short for change directory. To change to that directory, say if I wanted to open the pictures directory, I'd do cd pictures. where again we want to find out the contents of the pictures directory, and to do so we use ls again. So in this case, it looks like there are 4 pictures of dogs given from the screenshot. Okay, outputting the contents of a file, which is cat. Whilst knowing about the existence of files is great, it's not all that useful unless we're able to view the contents of them. We will come on to discuss some of the tools available to us that allows us to transfer files from one machine to another in a later room. But for now, we're going to talk about simply seeing the contents of text files using a command called cat. Cat is short for concatenating, and is a fantastic way for us to output the contents of files, not just text files. In the screenshot below, you can see how I have combined the use of ls to list the files within a directory called documents. So we've applied some knowledge from earlier in this task to do the following. 1. Used ls to let us know what files are available in the documents folder of this machine. In this case, it is called todo.text. We have then used cat todo.text to concatenate output the contents of this todo.text file, where the contents are here's something important for me to do later. So finding out the full path to our current working directory, which is pwd. You'll notice as you progress through navigating your Linux machine, the name of the directory that you are currently working in will be listed in your terminal. It's easy to lose track of where we are on the file system exactly, which is why I want to introduce pwd. This stands for Print Working Directory. Using the example machine from before, we are currently in the Documents folder. But where is this exactly on the Linux machine's file system? We can find this out using the pwd command, like within the screenshot below. So let's break this down. 1, we already know we're in Documents thanks to our terminal, but at this point in time we have no idea where Documents is stored so that we can get back to it easily in the future. 2, I've used the pwd print working directory command to find the full file path of this Documents folder. 3, we're helpfully told by Linux that this Documents directory is stored at /home/ubuntu/documents on the machine. Great to know. 4, now in the future, if we find ourselves in a different location, we can just use cd/home/ubuntu/documents to change our working directory to this Documents directory. And then it goes to questions. Task 6 is searching for files. Although it doesn't seem like it so far, one of the redeeming features of Linux is truly how efficient you can be with it. With that said, you can only be as efficient as you are familiar with it, of course. As you interact with OSs such as Ubuntu over time, essential commands like those we've already covered will start to become muscle memory. One fantastic way to show just how efficient you can be with systems like this is using a set of commands to quickly search for files across the entire system that our user has access to. No need to consistently use cd and ls to find out what is where. Instead, we can use commands such as find to automate things like this for us. This is where Linux starts to become a bit more intimidating to approach, but we'll break this down and ease you into it. Using find. The find command is fantastic in the sense that it can be used both very simply or rather complex depending upon what is you want to do exactly. However, let's stick to the fundamentals first. Take the snippet below, we can see a list of directories available to us. So the list of directories are 1 desktop, 2 documents, 3 pictures, and 4 folder 1. Now, of course, directories can contain even more directories within themselves. It becomes a headache when we are having to look through every single one just to try and look for specific files. We can use find to do just this for us. Let's start simple and assume that we already know the name of the file we're looking for, but can't remember what it is exactly. In this case, we're looking for passwords.txt. If we remember the file name, we can simply use find minus name passwords.txt, where the command will look through every folder in our current directory for this specific file like so. Find has managed to find the file. It turns out it is located in folder 1/passwords.txt. Sweet. But let's say that we don't know the name of the file or want to search for every file that has an extension such as .txt. Find lets us do that too. We can simply use what's known as a wildcard, which is a asterisk, to search for anything that, or no, a star, not asterisk, to search for anything that has .txt at the end. In our case, we want to find every .txt file that's in our current directory. We will construct a command such as find dash or minus name, I forgot what that's called, name asterisk .txt, where find has been able to find every .txt file and has then given us the location of each one. Find has managed to find 1 passwords.txt located within folder 1, 2 to-do.txt located within documents. That wasn't so tough, huh? Using grep. Another great utility that is a great one to learn about is the use of grep. The grep command allows us to search the contents of files for specific values that we are looking for. Take, for example, the access log of a web server. In this case, the access log of a web server has 244 entries. Using a command like cat isn't going to cut it too well here. Let's say, for example, if we wanted to search this log to see things that a certain user/IP address visited. Looking through 244 entries isn't all that efficient considering we want to find a specific value. We can use grep to search the entire contents of this file for any entries of the value that we are searching for. Going with the example of a web server's access log, we want to see everything that the IP address 81.143.211.90 has visited. Note, this is fictional. So, grep has searched through this file and has shown us any entries of what we've provided and that is contained within this log file for the IP. Task 7, an introduction to shell operators. Linux operators are a fantastic way to power up your knowledge of working with Linux. There are a few important operators that are worth noting. We'll cover the basics and break them down accordingly to bite-sized chunks. At an overview, I'm going to be showcasing the following operators. So the symbol or operator, which is ampersand, this operator allows you to run commands in the background of your terminal. And the symbol, the double ampersand, this operator allows you to combine multiple commands together in one line of your terminal. And the symbol greater than, this operator, or is it? Yeah, greater than. This operator is a redirector, meaning that we can take the output from a command, such as using cat to output a file and direct it elsewhere. And the double greater than symbol This operator does the same function of the greater than operator, but appends the output rather than replacing, meaning nothing is overwritten. Let's cover these in a bit more detail. The operator ampersand. This operator allows us to execute commands in the background. For example, let's say we want to copy a large file. This will obviously take quite a long time and will leave us unable to do anything else until the file successfully copies. The ampersand shell operator allows us to execute a command and have it run in the background, such as this file copy, allowing us to do other things. The operator double ampersand. This shell operator is a bit misleading in the sense of how familiar it is to its partner ampersand. Unlike the ampersand operator, we can use double ampersand to make a list of commands to run, for example, command 1 and double ampersand command 2. However, it's worth noting that that command 2 will only run if command 1 was successful. The operator greater than. This operator is what's known as output redirector. What this essentially means is that we take the output from a command we run and send that output to somewhere else. A great example of this is redirecting the output of the echo command that we learned in task 4. Of course, running something such as echo howdy will return howdy back to our terminal. That isn't super useful. What we can do instead is redirect howdy to something such as a new file. Let's say we wanted to create a file named welcome with the message hey. We can run echo hey with this greater than operator, welcome, where we want the file created with the contents hey, like so. Operator double greater than. This operator is also an output redirector, like in the previous operator we discussed. However, what makes this operator different is that rather than overwriting any contents within a file, for example, it is instead just puts the output at the end. Following on our previous example where we have the file welcome that has the contents hey, if we were to use the echo to add hello to the file using the greater operator, the file will now only have hello and not hey. The double greater than operator allows to append the output to the bottom of the file rather than replacing the contents like so. Task 8, Conclusions and Summaries. Nice work on getting on to this stage. We've covered quite a bit for your first interactions with Linux. However, these are the most essential functions you're going to be using whenever you interact with a Linux machine. I hope this room hasn't been too daunting for you to power on through with. It's as I previously mentioned, you're going to become familiar with these things very quickly because of how often you're going to be using them. To quickly recap, we've covered the following. 1. Understanding why Linux is so commonplace today. 2. Interacting with your first ever Linux machine. 3. Ran some of the most fundamental commands. 4. Had an introduction to navigating around the file system and how we can use commands like find and grep to make finding data even more efficient. And 5. Power up your commands by learning about some of the important shell operators. And it says to take some time to play around with the room, the virtual machine. Linux Fundamentals Part 2. Continue your learning Linux journey with Part 2. You will be learning how to log into a Linux machine using SSH, how to advance your commands, file system interaction. Task 1, Introduction. Welcome to the second part of the reworked Linux Fundamentals series. We'll be applying our knowledge from the first installment in this series, so I highly recommend you completing that room before proceeding further. In part 2, we'll be ditching the in-browser functionality and help you get started in what is a fundamental skill in being able to log into and control the terminals of remote machines. Not only this, but this room will also have you, 1. Unlocking the potential of your first few commands by introducing you to using flags and arguments. 2. Advancing your knowledge of the file system to perform some more useful commands such as copying and moving files. 3. Discovering how access to files and folders is managed and how we can determine our access. Running your first few scripts and executables. Let's proceed, and I think it goes, okay. There was no answer to that. Task 2, accessing your Linux machine using SSH, which is secured shell. In the browser functionality was used in Linux Fundamentals Part 1 to get you directly connected to your first ever Linux machine without any hassle. In fact, the in-browser functionality uses the exact same protocol that we are going to be using today. This protocol is called Secure Shell, or SSH for short, and is the common means of connecting to and interacting with the command line of a remote Linux machine. We will be deploying 2 machines in this room, your Linux machine and the TryHackMe attack box. What is SSH and how does it work? Secure Shell, or SSH, simply is a protocol between devices in an encrypted form. Using cryptography, any input we send in a human-readable format is encrypted for traveling over a network, where it is then unencrypted once it reaches the remote machine, such as the diagram below. You can learn about the various types of encryption on TryHackMe Room, but for now we only need to understand that SSH allows us to remotely execute commands on another device remotely. And second, any data sent between the devices is encrypted when it is sent over a network, such as the internet. Deploying your Linux machine. So just showing you pictures of what it's supposed to look like. The IP address displayed is the address of your Linux machine that you will be logging into using SSH. Take note of this for now. That's deploying the TryHackMe attack box. Looking at the top of the page, press the attack box button to deploy the TryHackMe attack box that we will be interacting with. The TryHackMe attack box is a Ubuntu Linux machine that is hosted online in the cloud and can be interacted with via your browser. You will be using this to interact with the machine that you deploy in this task. Using SSH to log into your Linux machine. The syntax to use SSH is very simple. We only need to provide 2 things. 1, the IP address of the remote machine, and 2, correct credentials to a valid account to log in with on the remote machine. For this room, we will be logging in as TryHackMe, whose password is TryHackMe without the quotation marks. Let's use the IP address of the machine displayed in the card at the top of the room as the IP address and this user to construct a command to log into the remote machine using SSH. The command to do so is SSH, that's what it looks like, and then the username of the account, which is the @ symbol, the IP address of the machine. But first we need to open a terminal on the TryHackMe attack box. There is an icon placed on the desktop named Terminal, and now we can proceed to input commands. For example, SSH TryHackMe at machine_IP. Replacing the IP address with the IP address for your Linux target machine, once executed, we will then be asked to trust the host and then provide a password for the TryHackMe account, which is also TryHackMe. And if you're doing this lab, when you're typing in the password, you're not going to see it. It's not going to be shown. So after you're done typing it, just press enter and you'll, because that confused me while I was doing the lab. And it says, now that we are connected, any commands that we execute will now execute on the remote machine, not our own. Oh, and it even has a note. It says, when you type a password into an SSH login prompt, there is no visible feedback. You will not be able to see any text or symbols appear as you type the password. It is still working, however, so just type the password and press enter to log in. Task 3, Introduction to Flags and Switches. A majority of commands allow for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as flags or switches. We'll later discuss how we can identify what commands allow for arguments to be provided and understanding what these do exactly. When using a command, unless otherwise specified, it will perform its default behavior. For example, ls lists the contents of the working directory. However, hidden files are not shown. We can use flags and switches to extend the behavior of commands. Using our ls example, ls informs us that there is only one folder named folder 1, as highlighted in the screenshot below. Note that the contents in the screenshots below are only examples. However, using the -a argument for all, for short for --all, we now suddenly have an output with a few more files and folders such as .hidden folder, files and folders with a period, or hidden files. Commands that accept these will also have a $help option. This option will list the possible options that the command accepts, provide a brief description and an example of how to use it. What it's supposed to look like and what it gives you after you've pressed enter. This option is, in fact, a formatted output of what is called the man page, which is short for manual, which contains documentation for Linux commands and applications. The man, or the manual page. The manual pages are a great source of information for both system commands and applications available on both a Linux machine, which is accessible on the machine itself and online. To access this documentation, we can use a man command and then provide the command we want to read the documentation for. Using our ls example, we can use man ls to view the manual pages for ls, like so. Here it's supposed to look like in your terminal. Oh, and it then goes to questions. So you will basically get the answers to the questions if you're following along, but I just don't. I know how some people are, they just want the answers, they will skim through stuff. Okay, task 4, file system interaction continued. We've covered some of the most fundamental commands when interacting with the file system on the Linux machine. For example, we covered how to list and find the contents of folders using ls and find, and navigating the file system using cd. In this task, we're going to learn some more commands for interacting with the file system to allow us to 1. Create files and folders, 2. Move files and folders, 3. Delete files and folders. More specifically, the following commands, which is the command touch, its purpose is to create a file. The command mkdir, which is mkdir, its full name is to make a directory, and its purpose is to create a folder. The command cp, which stands for copy, its purpose is to copy a file or folder. The command mv, which is to move a file or folder. rm, which stands for remove, is to remove a file or folder, and the command file is to determine the type of a file. Creating files and folders such as touch and mkdir. Creating files and folders on Linux is a simple process. First, we'll cover creating a file. The touch command takes exactly one argument, the name we want to give the file we create. For example, we can create the file note by using TouchNote. It's worth noting that Touch simply creates a blank file. You would need to use the commands like echo or text editors such as nano to add content to the blank file. Here's a picture of using Touch to create a file. And this is a similar process for making a folder, which just involves using the mkdir command, and again providing the name that we want to assign the directory. For example, creating the directory as my directory using mkdir my directory. There's a picture of creating a directory with mkdir. And removing files and folders, which is rm. rm is extraordinary out of the commands that we've covered so far. You can simply remove files by using rm. However, you need to provide the -r switch alongside the name of the directory you wish to remove. And here's a picture of using rm to remove a file, and then another picture using rm recursively to remove a directory. Copying and moving files and folders with the cp and mv command. Copying and moving files is an important functionality on a Linux machine. Starting with cp, this command takes two arguments. One is the name of the existing file. Two is the name we wish to assign the new file when copying. cp copies the entire contents of the existing file into the new file. In the screenshot below, we are copying note to note 2. There's a picture of using cp to copy a file. Moving a file takes two arguments, just like the cp command. However, rather than copying and/or creating a new file, mv will merge or modify the second file that we provide as an argument. Not only can you use mv to move a file to a new folder, but you can also use mv to rename a file or folder. For example, in the screenshot below, we are renaming the file Note2 to be named Note3. Note3 will now have the contents of Note2. Here's a picture of using mv to move a file. Okay, determining file type. What is often misleading and often catches people out is making presumptions from files as to what their purpose or contents may be. Files usually have what's known as an extension to make this easier. For example, text files usually have an extension of .text, but this is not necessary. So far, the files we have used in our examples haven't had an extension. Without knowing the context of the file is there, we don't really know its purpose. Enter the file command. This command takes one argument. For example, we'll use file to confirm whether or not the note file in our examples is indeed a text file. Like so, file note. And here's a picture of using file to determine the contents of a file. Right here. Okay. Task 5 is Permissions 101. As you would have already found out by now, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access as we have and where it leads us. In our previous task, we learned how to extend the use of commands through flags and switches. Take, for example, the ls command, which lists the contents of the current directory. When using the -l switch, we could see 10 columns such as in the screenshot below. However, we're only interested in the first 3 columns. So, although intimidating, these columns are very important in determining certain characteristics of a file or folder and whether or not we have access to it. A file or folder can have a couple of characteristics that determine both what actions are allowed and what user or group has the ability to perform the given action, such as the following. 1 is read, 2 is write, and 3 is execute. Using the SU to switch to user 2, here's a picture. Let's use the smnatic.pem file. In our initial screenshot at the top of this task, it has the hyphen indicator highlighting that it is a file and then RW followed after. This means that only the owner of the file can read and write to this smnatic.pem file, but cannot execute it. Briefly, the differences between users and groups. The great thing about Linux is that permissions can be so granular that whilst a user technically owns a file, if the permissions have been set, then a group of users can also have either the same or a different set of permissions to the exact same file without affecting the file owner itself. Let's put this into real-world context. The system user that runs a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will have to want to allow their customers to upload their own files for their website without being the web server system user, compromising the security of every other customer. We'll learn the commands necessary to switch between users below. Switching between users. Switching between users on a Linux install is easy work thanks to the SU command. Unless you are the root user or using root permissions through sudo, then you are required to know two things to facilitate this transition of user accounts. One is the user we wish to switch to, and 2, the user's password. The SU command takes a couple of switches that may be of relevance to you. For example, executing a command once you log in or specifying a specific shell to use, I encourage you to read the man page for SU to find out more. However, I will cover the -L or double hyphen login switch. Simply by providing the -L switch to SU, we start a shell that is much more similar to the actual user logging into the system. We inherit a lot of properties of the new user, i.e. environment variables and the likes. Here's a picture of using SU to switch to user 2 interactively. For example, when using SU to switch to user 2, our new session drops us into our previous user's home directory. And here's a picture of using SU to switch to user 2 interactively. We're now, after using -L, our new session has dropped us into the home directory of user automatically. Task 6, Common Directories. /etc, which is etc. This root directory is one of the most important root directories on your system. The etc folder, short for etc., is a commonplace location to store system files that are used by your operating system. For example, the sudoers file highlighted in the screenshot below contains a list of the users and groups that have permissions to run sudo or a set of commands as the root user. Also highlighted below are the password or PASSWD and shadow files. These two files are special for Linux as they show how your system stores the passwords for each user in encrypted formatting called SHA-512. /var. The /var directory, with a var being short for variable data, is one of the main root folders found on a Linux install. This folder stores data that is frequently accessed or written by services or applications running on the system. For example, log files from running services and applications are written here, /var/log, or other data that is not necessarily associated with a specific user, i.e. databases and the like. So /root, unlike the /home directory, the /root folder is actually the home for the root system user. There isn't anything more to this folder other than just understanding that this is the home directory for the root user. But it is worth a mention as a logical presumption is that this user would have their data in a directory such as /home/root by default. /tmp. This is a unique root directory found on a Linux install, short for temporary. The /tmp directory is volatile and is used to store data that is only needed to be accessed once or twice. Similar to the memory of your computer, once the computer is restarted, the contents of this folder are cleared out. What's useful for us in pen testing is that any user can write to this folder by default, meaning once we have access to a machine, it serves as a good place to store things like our enumeration scripts. Task 7, Conclusions and Summaries. Nice work. This room was quite theory heavy and covered quite a range of the fundamentals in getting you familiar with Linux. To quickly recap, this room taught you 1. How to connect to a Linux machine remotely using SSH. 2. Advancing your use of commands by providing flags, switches, and where you can go to learn about these for each command, which is man pages. 3. Some more commands that you'll frequently be using to interact with the file system and its contents. 4. A brief introduction to file permissions and switching users. And 5. A summary paragraph of the important root directories on Ubuntu Linux install, and how we may be able to use the data stored within the database. It says, I encourage you to go through this room again once or twice to gain some familiarity with the concepts. After all, practice makes perfect. Okay, and it's task 8. So task 1, Introduction. Welcome to part 3 of the finale of the Linux Fundamental module. So far throughout the series, you have got hands-on with some fundamental concepts and use some important commands. This room is going to showcase some useful utilities and applications that you are likely to use day to day. You're also going to advance your Linux FU skills by learning about automation, package management, and service application logging. Task 2, deploy your Linux machine. And so I've already went over this. It just repeats itself. Use the following credentials to start your attack bots on TryHackMe. The IP address is machine_IP. Username is TryHackMe, and the password is TryHackMe. Task 3, terminal text editors. Throughout the series so far, we have only stored text and files using a combination of the echo command and the pipe operators greater and double greater. This isn't an efficient way to handle data when you're working with files with multiple lines and the sorts. Introducing terminal text editors. There are a few options that you can use, all with a variety of friendliness and utility. This task is going to introduce you to Nano, but also show you an alternative name, Vim, which TryHackMe has a room dedicated to. Vim as VIM. Nano. It is easy to get started with Nano. To create or edit a file using Nano, we simply use Nano file name, which is replacing file name with the name of the file you wish to edit. And here is a picture introducing Nano. Once you press enter to execute the command, Nano will launch. where we can just begin to start entering or modifying our text. You can navigate each line using the up and down arrow keys or start a new line using the enter key on your keyboard. And here's a picture of using Nano to write text. Nano has a few features that are easy to remember and covers the most general things you would want out of a text editor, including 1. Searching for text, 2. Copying and pasting, 3. Jumping to a line number, 4. Finding out what line number you are on. You can use these features of Nano by pressing the Control key, which is presented as an up arrow on Linux, and a corresponding letter. For example, to exit, we want to press Control and X to exit Nano. Vim is a much more advanced text editor. Whilst you are not expected to know all advanced features, it's helpful to mention it for powering up your Linux skills. Some Vim's benefits, albeit taking much longer time to become familiar with, includes 1. Customizable. You can modify the keyboard shortcuts to be of your choosing. 2. Syntax highlighting. This is useful if you are writing or maintaining code, making it a popular choice for software developers. 3. Vim works on all terminals where Nano may not be installed. And 4. There are a lot of resources such as cheat sheets, tutorials, and the sorts available for you to use. And TryHackMe has rooms showcasing Vim if you wish to learn more about this editor. Yep. I am thinking about doing or recording all the rooms here because I think that would be helpful. But of course, I'm not going to be showing answers and labs. Task 4. General Useful Utilities. Downloading files like widget or wget. A pretty fundamental feature of computing is the ability to transfer files. For example, you may want to download a program, a script, or even a picture. Thankfully for us, there are multiple ways in which we can retrieve these files. We are going to cover the use of widget. This command allows us to download files from the web via HTTP, as if you were accessing the file in your browser. We simply need to provide the address of the resource that we wish to download. For example, if I want to download a file named myfile.txt onto my machine, assuming I knew the web address, it would look something like this. Here's a picture of widget, https assets.tryacme.com/additional/Linux fundamentals/part3/myfile.txt. Transferring files from your host, SCP or SSH. SCP, which means secure copy, is just that, a means of securely copying files. Unlike the regular CP command, this command allows you to transfer files between two computers using the SSH protocol to provide both authentication and encryption. Working on a model of source and destination, SCP allows you to 1. Copy files and directories from your current system to a remote system. 2. Copy files and directories from a remote system to your current system. Provided that we know usernames and passwords for a user on your current system and a user on the remote system. For example, let's copy an example file from our machine to a remote machine, which I have neatly laid out in the table below. The variable, which is the IP address of the remote system, its value will be 192.168.1.30. The variable user on the remote system, its value would be Ubuntu. The variable name of the file on the local system, its value will be important.txt. And the variable, which is the name that we wish to store the file as on the remote system, its value is transferred.txt. With this information, let's craft our CSP command, remembering that the format of CSP is just source and destination. And here's a picture of CSP and what is supposed to be in the text. And now let's reverse this and lay out the syntax for using CSP to copy a file from a remote computer that we're not logged into. Variable IP address of the remote system. Oh, it's just repeating itself. This is slightly different from the previous screenshot. The variable name of the file on the remote system, its value would be documents.txt, and the variable that name the wish to store the file as on our system, its value is notes.txt. The command will now look like the following, right here. CSP Ubuntu at 192.168.1.30/home/Ubuntu/documents.txt notes.txt. Serving files from your host or web. Ubuntu machines come prepackaged with Python 3. Python helpfully provides a lightweight and easy-to-use module called HTTP server. This module turns your computer into a quick and easy web server that you can use to serve your own files, where they can then be downloaded by another computer using commands such as curl and wget. Python's 3 HTTP server will serve the files in the directory where you run the command, but this can be changed by providing options that can be found within the manual pages. Simply, all we need to do is run python 3-m http.server in the terminal to start the module. In the snippet below, we are serving from a directory called web server, which has a single named file. Here's a picture of using Python to start a web server. So now let's use wget to download the file using the machine_IP address and the name of the file. Remember, because the Python 3 server is running port 8000, you need to specify this within your wget command. For example, here's a picture of an example wget command of a web server running on port 8000. Note, you will need to open a terminal to use wget and leave the one that you have started the Python 3 web server in. This is because once you start the Python 3 web server, it will run in the terminal until you cancel it. Let's take a look in the snippet below as an example. A picture of downloading a file from our web server using wget. Remember, you need to run the wget command in another terminal while keeping the terminal that is running the Python 3 server active. An example of this on the TryHackMe attack box is below. One flaw with this module is that you have no way of indexing, so you must know the exact name and location of the file that you wish to use. This is why I prefer to use Updog. What's Updog? A more advanced yet lightweight web server, but for now let's stick to using Python's HTTP server. Task 5, Processes 101. Processes are the programs that are running on your machine. They are managed by the kernel, where each process will have an ID associated with it, also known as its PID or PID. Increments for the order in which the process starts, i.e. the 60th process, will have a PID of 60. Viewing processes. We can use the friendly ps command to provide a list of the running processes as our user session and some additional information such as its status code, the session that is running it, how much usage time of the CPU it is using, and the name of the actual program or command that is being executed. Note how in the screenshot above, the second process PS has a PID of 204, and then in the command below. This is then incremented to 205. To see the processes run by other users and those that don't run from a session, which is like a IE system processes, we need to provide aux to the ps command like so. ps a and then aux, which is aux. Note, we can see a total of 5 processes. Note how we now have root and Smnatic, Smnatic. Another very useful command is the top command. Top gives you real-time statistics about the processes running on your system instead of a one-time view. These statistics will refresh every 10 seconds, but will also refresh when you use the arrow keys to browse various rows. Another great command to gain insight into your system is the top command. Managing processes. You could send signals that terminate processes. There are a variety of types of signals that correlate to exactly how cleanly the process is dealt with by the kernel. To kill a command, we can use the appropriately named kill command and the associated PID that we wish to kill. To kill PID 1337, we'd use kill 1337. Below are some of the signals that we can send to a process when it is killed. 1. Sig term, which kills the process but allow it to do some cleanup tasks beforehand. The second one, which is sig kill the process, but it doesn't do any cleanup after that fact. And the last one is sig stop, which is to stop or suspend a process. How do processes start? Let's start off by talking about namespaces. The operating system, or OS, uses namespaces to ultimately split up the resources available on the computer, such as CPU, RAM, and priority processes. Think of it as splitting your computer up into slices. Similar to a cake, processes within that slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Namespaces are great for security as it is a way of isolating processes from another. Only those that are in the same namespace will be able to see each other. We previously talked about how PID works, or PID, and this is where it comes into play. The process of an ID or zero is a process that is started when the system boots. This process is the system's init on Ubuntu, such as systemd or systemd, which is used to provide a way of managing a user's processes and sits in between the operating system and the user. For example, once a system boots and initializes, systemd is one of the first processes that are started. Any program or piece of software that we want to start will start as what's known as a child process of systemd. This means that it is controlled by systemd, but will run as its own process, although sharing the resources from systemd to make it easier for us to identify and the likes. Getting processes/services to start on boot. Some applications can be started on the boot of a system that we own, for example, web servers, database servers, or file transfer servers. This software is often critical and often told to start during the boot up of the system by administrators. In this example, we're going to be telling the Apache web server to be starting Apache manually, and then telling the system to launch Apache 2 on boot. Enter the use of systemctl. This command allows us to interact with the systemd process daemon. Continuing on with our example, systemctl is an easy-to-use command that takes the following formatting. Systemctl, and then it's an option and option service. For example, to tell Apache to start up, we'll use systemctl start Apache 2. Seems simple enough, right? Same if we wanted to stop Apache. We just replace the option with stop instead of start like we provided. We can do 4 options with systemctl. 1 is start, 2 is stop, 3 is enable, and 4 is disable. An introduction to backgrounding and backgrounding in Linux. Processes can run in two states, in the background and in the foreground. For example, commands that you run in your terminal, such as echo, or things that sort will run in the foreground of your terminal as it is the only command provided that hasn't been told to run in the background. Echo is a great example of the output of echo will return to you in the foreground, but wouldn't in the background. Take the screenshot below for example. Here we're running echo hi THM, where we expect the output to be returned to us like it is at the start. But after adding the add operator to the command, we're instead just given the ID of the echo process rather than the actual output, as it is running in the background. This is great for commands such as copying files because it means that we can run the command in the background and continue on with whatever further commands we wish to execute, without having to wait for the file copy to finish first. We can do the exact same when executing things like scripts. Rather than relying on the AND operator, we can use Control plus Z on our keyboard to background a process. It is also an effective way of pausing the execution of a script or command like in the example below. This script will keep on repeating. This will keep on looping until I stop. Until I stop or suspend the process by using Control plus Z, as indicated by T upper arrow Z. Now our terminal is no longer filled up with messages until we foreground it, which we will discuss below. Foregrounding a process. Now that we have a process running in the background, for example, our script background.sh, which can be confirmed by using the ps-aux command, we can backpedal and bring this process back to the foreground to interact with. With our process background using the Control plus Z and the AND operator, we can use FG to bring this back to focus like below, where we can see the FG command is being used to bring the background process back into the terminal, where the output of the script is now returned to us. Task 6, maintaining your system, automation. Users may want to schedule a certain action or task to take place after the system has booted. Take, for example, running commands, backing up files, or launching your favorite programs on, such as Spotify or Google Chrome. We're going to be talking about the cron process, but more specifically, how we can interact via the use of cron tabs. Cron tab is one of the processes that is started during boot, which is responsible for facilitating and managing cron jobs. A cron tab is simply a special file with formatting that is recognized by the cron process to execute each line step by step. Cron tabs require 6 specific values. The min value is what minute to execute at. The hour value is what hour to execute at. DOM, D-O-M, is what day of the month to execute at. Mon, which is M-O-N, is what month of the year to execute at. And DOW, which is D-O-W, is what day of the week to execute at. And CMD is the actual command that will be executed. Let's use the example of backing up files. You may wish to back up CMNA, or documents every 12 hours. We would use the following formatting. An interesting feature of cron tabs is that these also support the wildcard or asterisk. If we do not wish to provide a value for this specific field, i.e. we don't care what month, day, or year it is executed, only that it is executed every 12 hours, we simply just place an asterisk. This can be confusing to begin with, which is why there are some great resources, such as the online cron tab generator, that allows you to use a friendly application to generate your formatting for you, as well as the site Cron Guru. Cron tabs can be edited by using crontab-e, where you can select an editor, such as Nano, to edit your cron tab. And there's pictures. Oh. Task 7. Maintaining your system package management. Introducing packages and software repos. When developers wish to submit software to the community, they will submit it to an apt repository or apt repository. If approved, their programs and tools will be released into the wild. Two of the most redeeming features of Linux shine to light here: user accessibility and the merit of open source tools. When using the ls command on Ubuntu 20.04 Linux machine, these files serve as a gateway/registry. Whilst operating system vendors will maintain their repositories, you can also add community repositories to your list. This allows you to extend the capabilities of your OS. Additional repositories can be added by using the add-apt-repository command, or by listing another provider. For example, some vendors will have a repository that is closer to their geographical location. Managing your repositories, which is adding and removing. Normally, we use the apt command to install software onto our Ubuntu system. The apt command is a part of the package management software also named apt. Apt contains a whole suite of tools that allows us to manage the packages and sources of our software and to install or remove software at the same time. Our method of adding repositories is to add the add-apt-repository command. We illustrated above, but we are going to walk through adding and removing a repository manually. Whilst you can install software through the use of package installers such as dpkg, the benefits of apt means that whenever we update our system, the repository that contains the pieces of software that we add also gets checked for updates. In this example, we're going to add the text editor Sublime Text or our Ubuntu machine as a repository, as it is not a part of the default Ubuntu repositories. When adding software, the integrity of what we downloaded is guaranteed by the use of what is called a GPG, which stands for GNU Privacy Guard keys. These keys are essentially a safety check from the developers saying, here's our software. If the keys do not match up to what your system trusts and what the developers use, then the software will not be downloaded. So to start, we need to add GPG key for developers of Sublime Text 3. Note that TryHackMe instances do not have internet access, and so we're not expecting you to add this to the machine that you deploy, as it would fail. 1. Let's download the GPG key and use apt-key to trust it. 2. Now that we have added this key to our trusted list, we can now add Sublime Text 3 repository to our apt sources list. A good practice is to have a separate file for every different community/third-party repository that we add. 2.1. Let's create a file named sublime-text.list and /etc/apt/sources.list.d and enter the repository information like so. 2.2. And now use Nano or a text editor of your choice to add and save the Sublime Text 3 repository into this newly created file. 2.3. After we have added this entry, we need to update apt to recognize this new entry. This is done using the apt update command. 2.4. Once successfully updated, we can now proceed to install the software that we have trusted and added to apt using apt install subline-text. Removing packages is as easy as reversing. This process is done by using the add-apt-repository space double hyphen remove ppa command, or by manually deleting the file that we previously added to. Once removed, we can just use apt remove software hyphen name here hyphen here apt remove sublime hyphen text. Task 8. Maintaining your system logs. We briefly touched upon log files and where they can be found in Linux Fundamentals Part 1. However, let's quickly recap. Located in the /var/log directory, these files and folders contain logging information for applications and services running on your system. The operating system, OS, has become pretty good at automatically managing these logs in a process that is known as rotating. I have highlighted some logs from these three services running in a Ubuntu machine. One is an Apache 2 web server. Two are logs for the fail to ban service, which is used to monitor attempted brute forces, for example. And the third one is the UFW service, which is used as a firewall. These services and logs are a great way in monitoring the health of your system and protecting it. Not only that, but the logs for services such as a web server contain information about every single request, allowing developers and administrators to diagnose performance issues or investigate an intruder's activity. For example, the two types of log files below that are of interest. One is the access log, and two is the error log. They are, of course, logs that store information about how the OS is running itself and actions that are performed by users, such as authentication attempts. Then it goes to questions. Task 9, Conclusions and Summaries. Welcome to the end of the Linux Fundamentals module. Your familiarity with Linux will improve as you get to interact with it over time. Linux has the potential to do very powerful things with relative ease, as you have hopefully discovered throughout this module. To recap, this room introduced you to the following topics. 1. Using terminal text editors. 2. General utilities such as downloading and serving contents using a Python web server. 3. A look into processes. And 4. Maintaining and automating your system by the use of cron tabs, package management, and reviewing logs. Continue your learning in some other TryHackMe rooms that are dedicated to Linux tools or utilities. One is bash scripting, and the other is regular expressions. So that is it for Linux fundamental section. You guys, thank you so much for watching this, and you have a good one. Thank you.